1, 2, 3. Hi, A3.
Bye.
Good luck on your mastery.
Hello.
Yay. All right, let's review this bell work number 1. If you need to update your Pear Deck with the correct answer as we go through this, excellent. If you have questions, let me know and we'll go through them. All right, got my drawing tool. Find the third side if necessary, written in simplest radical form. So we should have a square root in our answer. This is the hypotenuse, so that must be C. 4 could be A or C, or A or B, sorry, doesn't matter. I'm gonna call it A, I'll say B is the one I don't know. So we're doing Pythagorean theorem, A squared plus B squared is equal to C squared. 4 squared plus the unknown B squared is equal to 9 squared. 4 squared is 16. B squared, 9 squared is 81. When we subtract 16 on both sides, we get 65. And then square root both sides, and we should get B is equal to the square root of 65, which does not simplify. All right, bell work 2 said make a right triangle with these 2 points. So we should have made a triangle that looked like this. Again, if you need to update your Pear Deck while I'm going through this, do it. So you got your example. And now we have a right triangle. We could really easily find the lengths of these sides and find the distance, which is the dotted line, which is the hypotenuse of this now right triangle. So this side is 1, 2, 3, 4 units long. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. Do Pythagorean theorem again. A squared plus B squared equals C squared. These are the same numbers we had last time, except for last time we had the hypotenuse, and this time we're looking for the hypotenuse. So 4 squared plus 9 squared is equal to C squared. 4 squared is 16. 9 squared is 81. Is equal to C squared. Add those up, which should be 97 is C squared. This question said round to the nearest 10th. So when we square root both sides, we get C is the square root of 97, 9.84, which will round to 9.8. C is 9.8. Record. Bell work 3, we got a kite. We're supposed to find the length of A to C. In this kite, we've got information about BD being 14 units long, and then we've got these congruent marks here, which mean each of those sides are equal to each other. If each of those sides are equal to each other and they add up to 14, they must each be 7. So we can use that to find the, let's get some new colors going on here. We could find this side of the blue triangle, and we could find this side here of my green triangle, and then we would know the total length from A to C. Okay, so let's do that. Blue triangle, what do we got? We got a 7 here and a 9 here, and the thing we don't know here. So A squared plus B squared equals C squared. The C here is the 9, so X squared plus 7 squared is equal to 9 squared. 7 squared is 49, 9 squared, 81. Subtract those, and we get X squared equals, what's 81 minus 49? 32. Square root both sides. What are we doing here? Nearest 10th of a centimeter. So I would leave 2 decimal places until the very, very end, and then we'll round. The square root of 32 is 5.66. 5.66. 5.66. Those are terrible numbers. Let's try that again. 5. Do better, Atkin. There you go. 6, 6. So that is the length from C to E. And now let's do same type of thing with our green triangle. We got a 10. We got that same 7. I'm going to call this Y. You can't tell that's number 7. Now we know that's number 7. Let's call this Y. 10's the C. So we got Y squared plus 7 squared is equal to 10 squared. 7 squared is still 49. 10 squared is 100. Subtract those and we get Y squared is 51. Square root both sides. Y is equal to, I don't know, square root of 51. 7.14. 7.14. So that's 7.14 from E to A. And then we just add those suckers up. 7.14 plus 5.66. And we get 12.8 for the total distance. We added these up to get our total distance of 12.8 centimeters. All right, bell work 4, find the side length of X in simplest radical form with the rational denominator. This is a 45, 45, 90 triangle, and in our model, the 45, 45, 90 triangle model, I'm going to call these A. The side lengths are the same. They're both A, and the hypotenuse is A square root of 2. We are given that the hypotenuse is 3, and we're trying to find a side length. So what I would always do is set what you are given equal to what it is in the model and solve for the variable, and then use the variable as you need to. So we'd have A square root of 2 is equal to 3. To get A by itself, we divide by the square root of 2 on both sides. So we get A is equal to 3 over the square root of 2. But we have to rationalize the denominator and get that square root out of the bottom. So multiply by square root of 2 over square root of 2, and we're going to get 3 square root of 2 over 2 would be the value for A in the model, which is great because that's the side we're looking for. So X is equal to that 3 square root of 2 over 2. Resume. Last question, find the length of the side, simplest radical form. This time we have a 30, 60, 90 triangle. So our 30, 60, 90 triangle model says that the side across from the 30, I'm not going to use the letter X, I'm going to call it A. The side across from the 30 is some number A. The hypotenuse is twice that number, and the side across from the 60 is that number times the square root of 3. Now we are given the square root of 3 is the side across from the 30, so that's equal to A. So A is equal the square root of 3. We are supposed to find the side across from the 60. Side across from the 60 is that number times the square root of 3. So X is A times the square root of 3. X is the square root of 3 times the square root of 3. And we know that a square root times itself is whatever is underneath the square root. So X is equal to 3. Good luck, A3. Good job, guys. Go get it.